different place you grew up.
Say again?
I said you must have grew up in a different area or something. What you guys did in boot camp, being Boy Scouts is
Oh, just stuff like this.
lots of fun.
Yeah, stuff like this. The mirror case, you still want to measure something like a tree. So here's the tree you want to measure. Say it's over here. Okay, here's the tree over here. And you stand somewhere over here. Now we're not making this anywhere near to scale, if you believe that. 6 feet. So you're still 6 feet tall. Okay? And then what you do is, assuming that the ground between you is flat. So over a short distance, that's a good assumption. Good assumption over a short distance. What you do is, you put a mirror on the ground. I had to borrow this from our admin. Promised to bring it back in one piece. And you back up or move forward until you can see the tip of the tree in the mirror. So you try to center it best you can in the mirror. So you back up, you move forward, you might have to move around a little bit. What a lot of people do is they pick the mirror up, find the tree, and then kind of put it down and move around until they can find it. Make sense? So then what you've got is you've got your line of sight from your eyes down to the mirror, and then from the mirror up to the top of the tree. Now, you already have two angles that you know are equal. One in one triangle, the one in the other. And what are the gimmies? The gimme angles are the 90s. Assuming that you're standing up straight, and assuming the tree is growing perpendicular to the ground, those are fair 90s. And then there's a pretty important law from physics that you may have picked up at some point in your physics lessons. If you haven't, if you have a laser pointer and a mirror in your house, this is awesome fun. This is awesome fun. If you have a cat and a laser pointer and a mirror, totally messing with this. When a light beam, or your line of sight, hits a mirror, like when a light hits a mirror, it bounces off. But what makes it interesting is it bounces off at the same angle that it goes in. It's called angle of incidence equals angle of reflection. You may have heard that at some point. You've noticed if you're fishing in clear water and you look down and you say, oh, look at that fish down there, and you reach down, like kind of try to touch it and point it. You know how your arm kind of bends? There's a refraction difference in things like water. In air, there is no such refraction. So there's an angle that you come in at. The angle that you exit at is the same. Well, I say you, light. The angle that light exits at is the same. Do you see now you now have similar triangles? You do, don't you? Because if this one equals this one, and this one equals this one, these guys up here have to be equal, don't they? Not that you need them, but they're forced to be equal for the same reason the third angles over here were forced to be equal. Is that a fair statement? Then all you gotta do is figure out these two distances right here. This is where your partners come in handy. You leave the mirror there, and you have a partner measure from the mirror to your feet, and then you have another partner measure from the mirror to the tree. Get those two distances. Let's call them, this might not come out to the same number. Oh, what the hell, let's just make it the same number. 3 and 60. There. Just make that be exactly the same. Why not? Or should we make them different to prove a point? Make them different to prove a point? Yeah, maybe. That's a good idea, actually. Let's just throw them out. Throw them out differently. Suppose this is now 8 feet. Suppose that's now 8 feet. Is that fair if I just just change it, be all crazy with the numbers? Make that 8 feet, and then, say again? What am I going to make this? 72! I love it. 72 feet. I love that. It's a fantastic idea. Yeah. Then just take your proportion up and solve it. All you got to know is which sides correspond to which sides. Now, it's pretty obvious which corresponds to the 6. 6 feet corresponds to the tree, exactly. So your 6 feet corresponds to what you're looking for in the tree, the t variable. Then you got to grab this triangle here and grab another. Now I'm going back to this triangle because I started in this triangle. 6 feet here is t over there. 8 feet here is the same as 72 is over here. Will, you were saying something back there. You were like, wait a minute, why didn't he do it that way? Why didn't he go 6 feet is to 8 feet? Why didn't he go 6 feet is to 8 feet as t is to 72?
Yeah.
Why didn't I?
We could have.
We could solve both. Solve both of them. Solve both equations right now. Equation boot camp, part the third.
It's still the same, though.
Solve